Hello. So this was the problem I provided in the previous class, and I told you to find the stresses on this AB plane, okay, using stress transformation equations, okay. So these are the final answers. I hope you got this, and if you did not got these answers, so let us solve this problem and see what we do, okay. So basically we can solve this problem two ways, okay. So first is we can assume a clockwise rotation of horizontal plane 50 degrees, right, or we can also assume an anti-clockwise rotation of the vertical plane, okay. So if we assume this, that the horizontal plane have an is rotated by 50-degree clockwise, okay, this then it is one way of solving, and the other way of solving is that this is the vertical plane and this much is the anti-clockwise, right, anti-clockwise rotation, okay. So by the way, how much is this? Now this is total is this is 90 degrees, right, and this is 50. We know the sum of the angles of our right angle triangle, planar triangle, is 180 degrees, so it has to be 40 degree, right, because 50 plus 40 is 90 and 90 plus 90 is 180 degrees, okay. So one way is we can assume this rotation of, this is our AB plane, right. So either we can assume this 50 degrees clockwise angle, right, of the horizontal, or we can assume this plane has rotated with 40 degrees anti-clockwise, okay. So we can also assume this, okay. So first of all I will assume this 50 degrees clockwise rotation, then I will assume 40 degrees anti-clockwise, and again as it is an assumption, so both the ways we should get the same answer, okay. So let us try both the ways, okay. So here I have shown these two. So let me first draw the original coordinate axis. So let us say this is the original coordinate axis, right, like this, okay. So I will draw it here for clarity, and let us draw the transformed coordinates. It is like this, right, which is clockwise 50 degrees, right, it is like this, right. So I will show it here. So this we have a 50 degrees, but it is clockwise, right. So let us say if we assume this was the original x axis, this is the original y axis. By original I mean before the transformation, okay. Now when you rotate it, okay, so let us rotate each and every one. So because this is 50 degrees, so it is also going to be 50 degrees. So this one is also going to be 50 degrees, and this one is also going to be 50 degrees, okay. Now let us see our transformed axis, okay. Now this x axis is transformed to this axis, okay. So it has to be x prime, right. So this y axis is transformed to this axis, so it is y, so this has to be y prime, okay. So if we draw our body here, half of the body, we will draw this, okay. This is A, this is B, okay. Then we have here, it is, how much is it, how much is this, it is 60, right, 60, this much is 40 degrees, right. I will show it here. Both of them are not 40 degrees, I mean 40 megapascal, right. Now we have this is 80, okay, this one is 80 megapascal, right. And now this is the y prime, so it is going to be, y prime is going to be here, right. And where is the x prime? So this one is the x prime, so it is this one, okay. So this is the x prime, okay. So you can see here what is the normal stress here. The normal stress is here along the y prime, right. This is the normal stress, so it is going to be sigma y prime, right. And this is the x prime axis is along the AB, so it is going to be shear. Okay, so tau x prime y prime is along AB. Okay, now remember this is our angle, right? 50 degrees. This is our angle 50 degrees. Okay, so let us apply the transformation equations. Okay, so before applying transformation equations, let us see what is our sigma x, sigma y. Okay, the before rotation, right? So you can see this green is the let me first write, I will show you. I have assumed this is the x-axis, right? So this is the x-axis and this is the y-axis. These are the original, right, before rotation. So you can see this is the bright side. Okay, I mean the positive side, and this side is the negative side. Okay, so I told you in the sign convention, because these two things, these are from here, right? These two, this side and this side is this side and this side, and this is dark side or negative side, right? And in the negative side, I have told you in the previous class, if you have not watched that video class, please watch that. I have told you the sign convention in the negative side, it has to be, it is like opposite to the bright side. I mean, like for example, this one, this 80 megapascal is towards the x prime, but it is in the dark side, negative side, so it is negative. Okay, sigma x is minus 80 megapascal. Now sigma y is this, right? Sigma y is downwards, but it is on the negative side. So if it is opposite, then it is positive. Okay, so sigma y is 60 megapascal. And remember, if we consider these forces here on this side, if it was towards, for example, here the 60 is towards y, then it would have been positive. Okay, and here in this side the 80 is away from this, so it is negative here too. Okay, so we got sigma x and we got sigma y. Now let us see tau xy. Tau xy is, if we look at the bright side, we can look at any side. Okay, so here it is opposite, right? So it is negative. Okay, it is minus 40 megapascal. Okay, now if we see the same in the dark side, the negative side, then this is our shear stress 40 megapascal, and it is towards this. Okay, but since it is in the dark side, so if it is along the same direction, then it is negative. Okay, so both ways we can find them. Okay, and the angle we have 50 degree clockwise, and we know in the stress transformation equations a clockwise angle is taken as positive and the anti-clockwise is negative. Okay, since 50 degree is clockwise, so it is negative. Okay, so now let us apply the stress transformation equations. We know now we are going to apply sigma y prime. Okay, not sigma x, because the normal stress here is sigma y. Okay, so sigma y prime is sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 times cos of what? Cos of, is it 2 theta or 2 times 90 minus 90 plus theta? Because it is the y prime, it is 2 times 90 plus theta. Okay, then plus tau xy shear stress sine of, is it 2 theta or 2 times 90 plus theta? Because it is y prime, it is 2 times 90 plus theta. If it was sigma x prime, if you remember from a previous class, then it would have been 2 times of theta. Okay, and remember I told you in the previous class, if we want to find the sigma y prime, because we have to find the sigma y prime right here, as you can see, because y prime is our normal stress, so we have to find the sigma y. We don't have to find the sigma x here, right? So in the sigma y prime we add 90 to theta. Okay, and if it was sigma x prime, then it would have been 2 times theta, not 90 plus theta. Okay, anyways, so sigma y prime, so let me just write here. So sigma x is minus 80 megapascal, sigma y, as you can see here, it is 60, so it is minus 80, it is 60. Now 90 plus 2 times 90 plus theta. Now how much is theta? Theta is minus 50 degree, right? So how much is 90 plus theta? So it is 90 plus minus 50, which is 40 degrees, right? So it is 40 degrees, and it is also going to be 40 degrees. Okay, so let me use a calculator to find the values. Okay, again, this tau xy, it is what? It is minus 40 megapascal. Okay, so let me use a calculator to find the values. It is minus 80 plus 60 divided by 2 plus minus 80 minus 60 divided by 2 times cos of 2 times cos 2 times 40, right? 2 times 40 plus tau xy. Now tau xy is negative 40 times sine of 2 times of 40, right? Sine of 2 times of 40. So we got sigma y prime to be minus 61.55 approximately. Okay, megapascal. Okay, so we got this this normal stress of negative. Negative means it is going to be towards AB. Okay, now let us find the shear stress on the AB plane. It is going to be tau x prime y prime is equal to, remember the formula, it is negative sigma x minus sigma y divided by 2 times sine of, remember we can apply 2 times 90 plus theta. Okay, but we don't have to. Okay, because tau xy is going to be same if we consider a clockwise angle, if we consider, you know, if we consider this angle. Okay, or if we consider this angle. So since tau xy is going to be same, you can also choose it to be 2 times theta. Okay, it does not matter. Okay, so what matters here is only sigma. In the sigma x prime we add 2 times theta, and in the sigma y prime we add 90 plus theta. But in the tau x prime y prime, since they are the same, if we assume whatever the angle, so we can assume it here 2 times theta, not 2 times 90 plus theta. Okay, plus tau xy cosine of 2 times theta. Okay, so let us put the values. Okay, now we already know the values. It is negative sigma x we got as minus 80, and this is sigma y is 60, tau xy is minus 40. Okay, and theta we have is negative 50, right? Theta here is negative 50. Okay, so let's put the values. So it is going to be minus 80 minus 60 divided by 2, but it's negative, right? Sine of negative 2 times 50, right? Because theta is minus 50, plus tau xy is minus 40 times cosine of negative 2 times 50, right? So it is approximately minus 62 megapascal. Okay, so if we draw these, this is our AB. Okay, now sigma y is outward, but we got a negative. It means it is towards this, all right, opposite to what we assume, right? Because it is negative, so it is 61.55 megapascal. And then tau xy is negative 62. Negative means here it was towards B, but we got a negative answer. It means it is towards A, right? Opposite to what we assume here. Okay, so here it is 62 megapascal. Okay, now if we compare it with our answer here, if we compare it with our answer, let us compare it. Here it is So you can see 61.55 we got it, it is towards AB, so this is right, and 62 megapascal is towards A, right, and 62 megapascal is towards A, right. So our answer is correct. Okay, so now let us solve it the other way. Okay, so let me erase this, then I will assume, I won't assume this minus 50, I will assume this angle. Okay, so let me erase this first, and then we will solve it using this angle. Okay, okay, now let us assume. So now this time I am going to assume this angle. Okay, now again let me show it here. This is AB, right, this angle is 50, right, this angle is 90, right, because we know this is a right angle triangle, right, this is a right angle triangle here, right. So we know the sum of angle is 180 degrees, right. So this should be the sum of this angle plus this angle plus this angle should be 180. So 50 plus 40 is 90, and 90 plus 90 is 180, and we got 180 degrees. Okay, so right here we have a 40 degrees, it is anti-clockwise. Okay, and we know, I have told you in the previous class, if theta is angle of rotation is anti-clockwise, then it is negative, it's positive, right, 40 degrees. Okay, so now let us rotate, let us add these axes and see if in the normal axis do we get sigma x or sigma y this time. Okay, so let me add the original first. So here it is this, right, this is the original, and let us draw the transformed axis. Okay, so this is the transformed axis like this, right, so if I draw them here for clarity, so this is our angle, right, so it is here, right, this is 40 degrees anti-clockwise, right, and if it is 40 degrees, it means this is also going to be 40 degrees, this is also going to be 40 degrees, I mean one after the other. Okay, this is also going to be 40 degrees. Okay, so the alternative angles are going to be 40 degrees, all equal and all of the same direction. Okay, so this is our original x-axis, this is our original y-axis. Now this x-axis got transformed by 40 degrees, so this is our x prime axis, and this y-axis got transformed to this, so this is our y transformed axis. Okay, y prime axis. Okay, now if we again draw this, okay, so this is our A, this is our B, and if we look at this, so you can see here this is x prime now, right, this is x prime and this is y prime, so it is, this one is y prime, right, so this is x prime, this is y prime, right, as you can see here. Okay, now here we are going to assume sigma x prime. Okay, and here we are going to assume sigma y, not sigma, because it is along, and along the plane we have shear, not the normal. Okay, because sigma denotes the normal stress and tau denotes the along or the shear. Okay, so this is tau x prime y prime. Okay, now you can see the difference. When we assume this 50 degree clockwise, we got sigma y, right, we got sigma y here. Okay, I have erased it, but I hope you remember. Okay, now again here we have these stresses. Okay, this is 60 and this is our shear stress, this is 40 and this is our 80, right. Now again, what are these, what are the sign conventions? Now again we can take the sign convention from the positive side, from this side, as I have done in the earlier, or we can take it from this side. Okay, but we will take it from this, because in the positive side, because this is the positive side. Why is this a positive side? Because the original axis is like this, right? This is x axis, this is y axis, right? So these two are the original sides and these two are the opposite or the negative sides. Okay, so in the positive side, whatever is in this direction is positive and whatever is opposite to these axes is negative. Okay, now 60, here it is in this direction, okay, and it is in the y direction, so it is sigma y. So sigma y is positive, right? So sigma y is 60. Now sigma x is opposite, so sigma x is minus 80, right? And tau xy, it is this, it is opposite, right? So tau xy is negative 40, right? You can also see this here, this is tau xy, and we will compare it with this. They are opposite, so it is, they are negative. Okay, anyways, we got the data. Okay, now if we apply sigma x, now we have to apply sigma x prime here, right? In the previous assumption, we found sigma y prime because this is what we got here. Okay, but here we got sigma x prime, so it is sigma x prime is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cosine of 2 times of theta. Remember, it is not 90 plus theta because in sigma y prime we consider 90 plus theta. Okay, plus tau xy sine of 2 theta. Okay, then we have tau xy x prime y prime, it is negative, here it was positive. Okay, sigma x minus sigma y by 2, here it is cosine, but in the tau xy it is going to be sine of 2 theta plus 2 times of tau xy. Here it is sine, but in the tau xy it is going to be cosine. Okay, 2 theta. Okay, so in the both cases, let us apply the sigma x. Okay, these are our values. Okay, this is our angle theta, right? These are our stresses. So let us put these values in the calculator. Okay, so let me use the calculator. Sigma x is minus 80, then we have plus 60 divided by 2, then we have minus 80 minus 60 divided by 2 cosine of 2 times 40, right? Because theta is 40, right? As you can see here, theta is 40 degrees. Then we have tau xy is negative 40 sine of 2 times 40. So we got minus 61.55 approximately megapascal. Okay, now let us find the value of tau xy. It is negative sigma x minus sigma y by 2, it is minus 80 minus 60 divided by 2 times of sine of 2 times theta, theta is 40, then we have plus tau xy is negative 40 times cosine of 2 times 40, and we got it to be approximately 62 megapascal, right? So let us draw these. So this is our original stress, right? This is 40, this is 80. Okay, now let us draw these. Now we got minus 61.55 as the normal stress. Negative means compression, because this is the away from AB, because we got negative, it means it is opposite. Okay, so it is 61.55 megapascal. Now we got 62 megapascal as shear. Now 62 is positive, it means the same direction as this. Okay, 62 megapascal. Okay, now let us compare this also and see if we got the same answer. Okay, ideally we should get the same answer. Okay, because the assumptions doesn't matter. Okay, so let us compare. So again we got the same answer, 61 compression, 61.55 I mean. 62 towards A, 62 towards A, right? This is A, this is B, and here we got, okay, this was when we assume this. What was this? This was when we assume this, 50-degree clockwise, right? And this we assume 40 degrees anti-clockwise, but we got the same answer. Okay, I hope you understand. Again, if you have any doubts, you can comment. Okay, so that's it for today. See you in the next class. Thank you.